This morning we are looking at chemical bonding. In our chemical bonding is a process where a chemical compound attains octet structure or duet structure. When I say octet, it means their outermost electron is completely filled by the time two atoms react together. And in our previous class, we have looked at the types of chemical bonding, such as we have looked at electrovalent, we have looked at covalent bonding. And in those class we talk about electrovalent deal with a transfer of electron, where the one that transfer electron they are blown up, and to an atom that receive electron, those ones are referred to as acceptor. So there is transfer of electron from donor to acceptor. For instance, we look at Na plus Cl to form NaCl. So the sodium atom will transfer one electron to chlorine atom to complete its shell by forming sodium chloride. So sodium chloride is an example of covalent electrovalent compound. Then also we look at covalent. In covalent, there is a sharing of electron, whereby the two participating atoms donate electron to share. For instance, we look at chlorine gas. In chlorine gas, we look at a chlorine atom, Cl, another chlorine atom, Cl. When they are forming bond, so here the chlorine atom have 7 electrons in their outermost shell. This other chlorine atom too have 7 electrons in their outermost shell. So these two will pair to donate this electron and share by forming something like this. So here we have this. This electron will be donated by this one. We have this. And this other electron will be donated by this one. And in this case, these two of them, they are donating these 2 electrons and they will be sharing it. And at the end of the day, they form a chemical bonding in chlorine gas. That's what we have under covalent bonding. So this morning, we now want to look at other types of chemical bonding. So we want to look at dative coordinate bonding. Dative coordinate bonding. Dative coordinate bonding. In a dative coordinate bonding, this involves where 2 atoms react together, where only one will donate electron, the other one will not donate, and they will share to form a complete bond. For example, let's look at ammonia plus hydrogen ion. If you have ammonia plus hydrogen ion to form NH4, ammonia plus hydrogen ion to form NH. In ammonia, we have something like this. Nitrogen. For nitrogen, so this is H, and this is N. So here you have your HO, 1, 2, 3, 4, 5, 6, 7, 8. So this is ammonia, Na3. When it's now react with hydrogen ion, that is, hydrogen ion has lost no electron in it because hydrogen ion. Only one electron that is having. So by the time they now react together, we have formed something like this. They form something like this. This one so this one is still like this. Other one here, this, and for hydrogen you have XO. This other one that's going to pair with this, it will now react with this. This other one here, it will react to give us NH4. So you can see that in NH4, ammonium, hydrogen ion reacts with ammonia. This hydrogen ion is this. So in this case, this hydrogen ion is reacting, forming bond with this, but without contributing electron. And just only what sharing with these two pair of with a pair of electrons that is ammonia is having, this hydrogen ion is combining with this pair of electrons to also form bond. So when you have a chemical bond where two atoms react together, where only one donates electron, the other one does not donate electron, and they are sharing, that kind of bond is referred to as dative coordinate bond. Referred to as dative coordinate bond. So we also have another, in exam where you can be asked to identify the types of chemical bonding. If you are given a particular question, can be asked to identify type of chemical bonding you can see. What you can just see was just look at how that bond is being formed. How it's being formed. So in the coordinate bonding, see, this is, let's write something on this is what this is the type of chemical bonding where an atom donates electron and the other do not donate. Share electron. So see, this is type of chemical bonding where an atom donates an electron and the other does not donate and share electron. The sharing of electron, example is ammonium NH4 from NH3 and H plus. So NH4 formed from NH3, ammonia, NH4 is ammonium, formed from ammonia and hydrogen ion. So it's an example of covalent dative coordinate bonding. Dative coordinate bonding. So another type of bonding we are still having is metallic bonding. Metallic bonding. For metallic bonding, this is common to most metals. But most metals they have electrostatic force of attraction between an atom. You can see there is a kind of crystal. Let's say that this is a metal. Let's say that this is a metal. This metal have a kind of arrangement of electron. So there is a kind of force for electrostatic force of attraction. Attraction between what? Electron of forming a metal. And this one we now form of bonding. And this one responding for what? For high boiling and melting point of metal. That's why most metal have high boiling point because of form of metallic bonding between the crystal of their atom. Between the crystal of their atom. So let's write something here. This is a strong force of attraction. This is the force of attraction between electron cloud or a metal. So there will be a metal before electron cloud. So when you have electron cloud, there is also valence electron revolving around the if you have electron cloud like this, electron cloud, there will now be a free valence electron. So there will now be a force of attraction between what? A valence electron and electron cloud. So this is not normally responsible for what? The strong intermolecular band. And that's what you have under metallic bond. So this is a strong force of attraction between electron cloud of a metal and free valence electron. As always, metal always have free valence electron. Is that valence electron that metal was used to react? No, most metal, they are electron, they donate electron to anything they are reacting to. So that free valence electron, that is kind of what? A attraction between it and cloud of electron inside metal. And that is what we have under metallic bond. Example, you can see it in a copper. Any metal, you can see copper, iron, aluminum, zinc, lead. So all this one, what kind of bond you can find them is what? They are metallic bonds. So copper, iron, aluminum, zinc, lead. So they have a kind of bond called metallic bond. So another type of bond that we are seeing available is hydrogen bond. Hydrogen bond. Hydrogen bond. Hydrogen bond. For hydrogen bonding, this is common when hydrogen reacting, forming reaction with highly electronegative element. So if you look at the periodic table, let's say that you have a periodic, if you look at periodic table, in the periodic table we have what we call group and period. Let's say that this is group 1, group 2. Here, let's say that this is a group 3, group 4, group 5, group 6, group 7, and group 0. Group 0 is written as group 8. So, when they say highly negative, elements are those elements that can easily attract electrons to themselves. From I think here we have carbon, nitrogen, oxygen, fluorine, neon. Here we have sodium. If you look at periodic table very well, here should be carbon, lithium. Here is lithium. Here is beryllium, aluminium, magnesium first. Here we have aluminium here. Here we have so this is your periodic table. In the periodic table, all the elements in period 2. This is period 2. So those elements from nitrogen, oxygen, fluorine, they are highly electronegative elements. So reaction of hydrogen with any of them is referred to as hydrogen bonding. For example, now you can have hydrogen fluoride. If you have hydrogen fluoride, this is hydrogen fluoride. If you have hydrogen combined with fluorine, so this kind of bond is hydrogen bonding. The same thing if hydrogen combined with oxygen, and now you can see in water, H2O. When hydrogen combined with oxygen to form water, so kind of bond we can see there is what? Is hydrogen bonding. That's why water is having high boiling point. So that hydrogen bonding is responsible for high boiling and melting point of the compound. So generally when hydrogen form a kind of reaction with highly electronegative element, we form what we refer to as hydrogen bonding. And it's also responsible for why some substances that have hydrogen ionized in water, they dissolve. Why? Because when they see water, hydrogen ion there, they will react with hydroxide to solution. So that what we have under the hydrogen bonding. Let's write note on this. Can say hydrogen is what a bond is a bound form when hydrogen react with highly electronegative elements, such as oxygen, nitrogen, oxygen, nitrogen, and fluorine. Those elements where hydrogen combine with any of them before hydrogen bonding. So this force is in addition to the van der Waals. You know, van der Waals is a kind of force you can bonding you can find in gases, especially elements that have weak force, that have weak force. So hydrogen bonding react together in a kind of chemical compound. And let's go play before we apply. Let's look at the impact of hydrogen bonding on the compound. Let's look at the impact of hydrogen bonding on our compound. So here we have the following are characteristics of hydrogen, part of hydrogen bonding. The following are characteristics. Following are characteristics of impact of hydrogen bonding. What is the characteristics of hydrogen bonding? One. So hydrogen bonding is only for the high melting and boiling point. We have high melting, and boiling point. So any compound that is having hydrogen bond, you always have high melting point and high boiling point. Another one is high surface tension. We have high surface tension. And we are saying surface tension is deal with ability of a particular substance to prevent substance from passing through it. That is why you see water at times you drop object like a needle on water. At times you see the water seems to be holding the water from penetrating or holding the object from penetrating. It has to be the surface tension. So it will make the surface of a substance to behave like elastic skin. So it's one of the effects of hydrogen bonding. And also, hydrogen bonding also responsible for excellent solvent. Like I said, that's what I want to say, universal solvent. Why? Because anytime water reacts with any kind of hydrogen bonding, the hydrogen ion can react with hydrogen ion to dissolve, to form bonding. When you form bonding, be able to dissolve any substance that we call it excellent solvent. Solvent is something that can dissolve other substance. So lastly, the effect of hydrogen bonding is what? High latent heat of preparation. High latent heat of vaporization. So these are the effects of hydrogen bonding, on the impact of hydrogen bonding on what? particular chemical